Okay, so this third video is about types of designs, and I just want to, we're only going to talk about the very most basic design issues, design types here. This is just to get you into the understanding that it all comes down to between or within. So between means that are different people in each group, and they're measured one time on the variable. Within, or repeated, means that the same people are measured twice, or more than twice if the design is more complex. We can also have mixed designs where we combine factors that are between with factors that are within. So we might have somebody, we might manipulate something and then have somebody do it 4 times, and then those 4 times are a repeated factor, but then they either do this or that, and then that's a between factor. We will deal with mixed designs mostly next semester. So, huge terminology warning. I'm sorry. I'd love for you to watch this part of the video over and over again across the term, and we should remind ourselves of this. Between and within designs describe experimental situations where there are either different people or the same people in the design. Between and within subject variance estimates, describe statistical tools that are used in inferential statistics. So for t-tests and ANOVA, the numerator measures between group variability and the denominator measures within group variability. And honestly, the numerator is measuring variability that occurs between people or between conditions or between effects, and the error term is variability due to an individual or a subject. So within and between makes sense, but when we're talking about between subjects designs or between subjects experiments, it's not at all the same thing as when we're talking about between subjects variance. Between subject experiment, between subject design is about what the people are doing. Between subjects variability is where it is in a statistical formula. Not my fault, but we have to learn those terms. You have to be able to use both terms interchangeably correctly. All right, so on to design. So the first thing is post-test only design types. So you have 2 groups, 2 people, different people, and you eliminate everything about those those groups as much as possible. Random assignment is probably what we did. And then we manipulate something between those 2 groups. And then you measure the effect of that manipulated variable on some dV. So let's say that I was doing these videos twice, and you either saw this video with me wearing a tie or not wearing a tie. And wearing a tie, don't I look professional, right? When you wear a tie, you look more professional, right? And so I've got, let's say I had 2 conditions. It would introduce them. So I've got classes that I randomly assign the 15 of you to either to watch the video with the tie or without the tie, and then I measure learning or something else. So in the book, it's described with this figure. You've got this pool of participants. You randomly assign them either to the experimental group or the control group, and then you measure the dV. In contrast to post-test only, we could add a pretest to it. We could measure something about them beforehand and then see about change from pre to post. Now, however, you have 2 dVs. Now, however, you have 2 independent variables. One is the factor, the manipulation, whatever you manipulated, but also time. Pre and post is now a manipulation. So it's now a more complex design than just merely a paired t-test. In the book, we look at it like this. Participants at the beginning, we've got randomly assigned to either the experimental group or the control group. They all receive the exact same measure, the dV beforehand, and the same dV afterwards. So the problem is that it's more complex than a t-test. So you have to understand that your statistics need to match that. But you can assess equivalency with the small groups. So another story that I won't bring in here is Bob Rosenthal finding in his dissertation, using a pretest, that he found out that they differed at the pretest. And he realized this was due to experimental bias. So by using a pretest, you can identify differences between individuals to make sure they're the same. Because in a design, you want to make sure that the 2 groups are not different. We could also use them to select people for a group later. So maybe I give everybody an intro to psychology, a personality test, and I want to get the people that are either really extroverted or really introverted, really not extroverted, and to measure how they're responding to the stay-at-home order. I imagine that extroverts are probably not doing as well as introverts are. For the first time in my... No, that's not true. But certainly a rarity for extroverts to score lower on some social functioning than introverts. Maybe in attitudes, we want to get extreme political extremes in order to measure, I don't know, resolution of conflict or attitude extremity or something. So you give everyone an attitude scale and you get people in the extremes rather than worrying about these people in the middle where the effect might not be there. And then maybe in performance, you get some expert versus novice. Billiards is a great example, or a video game is a great example. Somebody is an expert at that task versus not. You want to get the extremes so that your effect is bigger. Remember the power, the bigger effect, more likely to find it. There are disadvantages. The first is that it can be more time consuming and awkward to administer. There can be mortality. People don't come back for the second time, and then you got to toss their data altogether. We're going to measure that bias in a moment with the Solomon 4 group design. But I also want you to recognize the other factor with pre-post test, which is that it sensitizes participants to what they're going to be doing. So you have demand characteristics, which means that something about the design lets you know what you're supposed to do as a participant. It reduces external validity. If I'm doing the manipulation twice, it's not likely the same as it is out in the real world, and there are possible order effects, which is another video altogether. So here's that 4-group design that we're going to use to try to identify whether or not there's an effect of the pretest. If we randomly assign participants to either be in the no pretest groups, so now we got 4 groups, the no pretest groups, these 2 groups up here, or to the pretest groups, and then each of the pretest groups get the measure. They don't. Half the groups up here are in the experiment group, half from the control group, and then you get the DV. Down below, again, half experimental, half control, and then you get a DV. You run the Solomon 4-group design, and then you look at your outcomes. If there is an effect of the pretest, you see outcome 2. If there's no effect for the pretest, you see outcome 1. See, if there's no effect of the pretest, then both the outcomes between control and treatment should be equal. But because there was an effect of the pretest in the second one, there's no difference between the post-test and there's no difference between the treatment and the control in the post-test only group. So basic design issues is it's either between or within. Between means different people in the groups. Post-test only is a good example of that. Within means that it's repeated. Pre-post test represents that part of that. Study designs dictate what statistics you use. Post-test designs have their own designs. Or pre-post designs have their own special challenges. Wow. Order effects, demand characteristics. Solomon 4-group design. We find out whether or not that's a problem. I'll see you in the next video.